Hello everyone. Let us now discuss how can we solve this question. Maximum number of points from grid queries. We are given with m by n integer matrix grid and an array queries of size n. So let us take this example that answer we need to return answer of size k such that for each integer queries I, you start in the top left cell of the matrix and repeat the following process. Let us see what is the process. If queries I is strictly greater than the value of the current cell that you are in, then you get 1 point if it is your first time visiting this cell, and you can move to any adjacent cell in all four directions: up, down, left and right. Otherwise, you do not get any points and you end this process. After the process answer I is the maximum number of points you can get. Note that for each query you are allowed to visit the same cell multiple times. Return the resulting array answer yes. So let us take this example and understand what is given in this question. So here the query is given as 5. Now I need the number of cells that I can visit, right? That I can visit, and they need the value should be less than 5 or my query. So this is the given in the question. I need the number of cells that I can visit, and the value of each cell that I visit should be lesser than 5. Now let us see what are the number of cells that I can visit. So I would start by leftmost cell 1. After 1, I got, as I am starting with 1, 1 is lesser than 5. So points till now, let me write number of points. Points till now are initially 0. But as the first cell, the starting cell is 1 and it is lesser than 5, it would be incremented by 1. So then can I go upside? No, it's out of box, not left. But I can go right. So 2 is lesser than 5. Yes. So if I increment, 2 is the points till now. So for 2, instead of going by a depth first search, by going through the depth, I would go by breadth. So I would check whether I can go down. Yes, then increment the number of points. It is 2, 3. Now here I got the first thing is 2. For 2, I would go to 3. Then is it lesser than 5? Yes. So increment our answer. Then for 2, I can't go left or I cannot go up. So I go to the down. But 5, is it lesser than 5? As they said, strictly greater than the value of current cell. That means cell value should be strictly lesser than the query value. So I don't go to 5. So let me explore this. I can't go left, I can't go up, I can go right, but 5 is not lesser than 5. So I go to the down and it is 3. So increment the number of points to 5. So the last number that I got is 3, but before that I got this 3. As in a queue you are using this breadth first search, so I can't go left as it is already visited, that I cannot go. They said this after yes, this thing something like note that for each query you are allowed to visit the same cell multiple times. That doesn't mean that in a path you can visit this cell again. That doesn't mean like that. It means after searching for query 0, after this query I can go to 1 again, I can go to 2 again, I can go to 3 again. So that means for every query we'll be using a new visited matrix. So that means every query is different. This query's answer doesn't affect the next query's answer. So that is given in the question. Don't be confused. So I can't even go to this, and so for 3 I can't go here as it is visited. I can't go here. Here I can go, but it is not lesser than 5. So the number of points till now are 5. So I think it's clear for you till now this question. For 6, this is the method 1, then go 2, and then go 2 till now 3. Now here 4, and then here 5, and then here 6, and then 7 here, and then here 8. Totally 8 points got for this query. Now let us see what is the brute force approach. Now I would use, first thing, as I said, I would use a breadth first search, use a BFS traversal for each query. Now, how can I use this BFS? By using DIRS, that means directions up, right, left, and down. Now, I have another thing that I need to do. So, instead of going through these queries, I can, even if I sort them, there is no use. So, instead of even sorting them, I would do a breadth first search in the for the answer for every query. Do BFS for every query in queries. So store that in an unordered map and return the answer at the end. No, I won't be giving you the intuition or the algorithm for this brute force, and even many of the people can solve it. But if you want the code, it is in the description. But let me go through the priority queue approach for this question. Now, I'm copying this image. I'm copying this image, pasting it here. So, in this question, right, we are given with queries like 5 and something like 6 and then 2. Now see clearly that from 1 I can go to 2. From 2, from 2, listen this carefully, that from 2 I can go to 3, and from 3 I can go to 7. From 7 I can't go to 5. But why? Let me show you that. From 1 I can go to 2, and also this 2 is also allowed. So there are 2 times these 2's. Now let me write this. What are the nodes, sorry, the cells that I can go? From this 2 I can go to 3. From this 2 I can go to 5. From this 2 I can go to 3. From this 2 I can also go to 5. From this 2 I can't go to 5. Because, why? Because from this 2 I went to this 5 and it is already visited. Why I need to visit this again? So this 2 would rather go to this 3. Now what are all those things which I have visited? All this 3, but these aren't explored. They are just visited. But if I explore this 3, 5 and 3, these things, from 3 I can go to 7. From 5 I can go to 7, this 5, this 5. But wait a second. Imagine you are given with a query q is equal to something like 5. Now, if I go from 5 to again 5, does it make sense? No, because imagine another query as 3, 3, right? From 3, would it be greater that if I go from 3 to 1? No. Why? Because this is decrementing the chances, or this isn't any answer for the query 3. Let me show you why. So here this 7 doesn't go to 3. doesn't go to 1 and it doesn't go to 5 as they all are lesser than 7. But for a clear intuition, till this 3, imagine you have a count that till this 3, I have 3 as the count. 3 as the number of cells that I can visit till now for this 3. Now, I have this 5. This till now I have 5. But imagine I wrote something like here I got from 5 to 5. But just imagine I got from 5 to 5. Then what are the number of cells that I can visit with query of 5? 1, 2, 3, 4. And then 5 and then 6. But if you see, I can only visit 5 cells here, right? That means there is a mistake here. That means simply I can't go from 5 to 5. Why? Why means I am storing this in an increasing order. Increasing order. So why does this help? Why shouldn't I go in decreasing order? Because see clearly that if I gone through from 5 to 5, when I get to this 5, I would be confused that whether I need to count this or not. As they said, from 5, if I gave with 5, I can go till lesser than 5. That's it. I can't go to 5 directly. So if I am having 4, then I can go to 5. But I have a 5 here, then I can't go to this 5 as it is not strictly increasing. As they asked strictly greater, that means I am in a reverse order that the cell should be strictly decreasing, sorry, lesser than the query. Now, is this clear for you? So is it it should be clear that I am storing it in an increasing order so that I would get a count, just a random thought. Now, so from this 5 I can't go to another 5. Now let me go and check whether what are other cells that I can go. For this 3 I can go to this 5. From this 5 I can't go to this 5, but from this 3 I can go to this 5. So let me write it over here. From this 3 I can go to 5. Now I have this 5 and it already visited and also explored that this is already visited and this is I can't go, so here it is 5. Now if I explore 7, as I said, I can't go with something like if the query is 1, I shouldn't be searching for 1. I shouldn't be searching for 1. If I am given with something like 6, I shouldn't be searching for 6. I should be returning till here what are the number of cells that I got. Till here I would get a count of, let me write it over here. Till here I would get a count of 3 for 6. Then this 3 would be added for this just and then 4. So in this path, I have 4 and 5 and then 6 and then 7. So there are 7 cells that I can visit with query 6, but it's just an example. So that here for 7, if I wrote a 1, clearly saying that this is the whole intuition for this question. So if I go from 7 to 1, this doesn't make a sense. This doesn't, that means I am storing this like for 1, query 1, I am going through 1, 2, 3, 7, 1. But 7 and 3 and 2 are greater than 1. So I can't store that in such a way. So when I store this in this way, that means till here I have 3 as the count, which are lesser than 3, which are lesser than 4. And here if I say for this 5, there are 1, 2, 3, 4, 5 nodes which are lesser, cells which are lesser than 5. So simply I can't store 1 after 7. Now This is the whole intuition, as I said that. But how can I implement this? How can I know the number of cells that I can visit for a given query? Now, let me say the query is, let me take the same example of 5. So 5, and then I am taking this 6 and 2. 6 and then 2. Now, you will be getting the answer why we will be sorting these queries in just few seconds. So 5, I would go from here, starting with here. So currently the points are initialized to 0, but the starting cell is 1, which is lesser than my query 5, so I would increment by 1 and it is 1. Then I go to this 2. I am not storing this either here, I am just storing in my current points. So it is lesser than 5, so increment the count. Then go to 3. Is it lesser than 5? Yes, so increment. Then is it lesser than 5? No, stop there. Then go backtrack, that means backtrack. So then go to 5. Is it lesser than 5? No. Then go back, and then here. Is it lesser than 5? Yes. Increment 4. Then go to 3. Is it lesser than 5? Yes. Increment the count. Here I got 5 as the count for this query 5. Now there is another thing 6. What I need to do now? I need to just check till here. See here. So for 5, I just got 5 as the number of cells. But what would be for 6? I would just add these two are the elements. So why should I just go through this all breadth first search again? Why shouldn't I store this in a such a way that I would store the elements in something like I would get 1, and then I would get 2, and then I would get 3, and then 7, and then 5, and then 2 again, and then 3 again, and then 5 again. Now, instead of going through 5, 6, and then 2, I would sort this. Sort this with, then I would get 2, 5, and then 6. Now, instead of current points, remove this current. Just store that as points. So, points initially points initially are 0, right? I got 2. First thing I got 2, right? So what are the number of cells that I can visit which are lesser than 2? Yes, only 1. Points would be incremented to 1. Now 2, is it greater lesser than 2? No, right? So I'm removing this and I'm incrementing my points to 1. So 2, is it, you know, yeah, next element is 2. Is it lesser than 2? No. So this query is over. For this query, I would make an answer that for this query, the answer is 1. Now, here I have 5. 2 is lesser than 5. So remove and increment the count to 2. Then I have 5. And here I have 3. Remove and increment the count by 3. Now I have 7. But if I store this in this way, I would not get these two queries. So instead I'll do one thing. I would go to the minimum element every time. I would use a priority. Use priority queue to get the minimum element every time. But why? So here I would say that from 1 and then 2 and then 3. So I would go through the elements which are only minimum. I would say how means here I would go to 1 and then to 2 and then for this 2. So 2 greater if I explain this here. Now From this one, as I said, I am exploring the lesser values first. From this one, I go to 2. So 1 and then 2 and then 2 again, 2 again. Then I would get 3 again. Then for this 3 and then 3 again. Then 5 and then 5 and then 7. But I get this one. But here I would also store the row and also the column. So every time I visit a cell which is unvisited, I would store that or push that in the priority queue with the row and also the cell. And if I can reach another cell, the adjacent cell which is unvisited and which is not out of bounds, and also which is lesser than the current cell. See here, the one is unvisited because there is no such cell that I can visit from another cell to this cell. I don't have a 0 here. If I had a 0, then I would visit this 1. So there is no way you can visit this one with any query. Even with 1, you would stop here itself. See here, you would stop here. So even you can't go with this one because for only 2, then I can visit 1. For 1, I would visit 0 cells because I need the query strictly greater than the cell value. So I would store the row and also the column, and I would go through all the adjacent elements, sorry, the cells, and then if they can be visited and they are lesser, sorry, the greater than the current cell, then I would push that back into my priority queue, which stores lesser values first. So it won't be storing this something like 1 2 3 7 5 2 3 5. It would be storing 1 2 2 and then 3 and then 3 and then 5 5 and then 7. This is how it stores. That means the minimum value first. This is how the priority queue works. You just need to know how to write this algorithm. You can write the algorithm. So the algorithm starts with initializing answer. Uh, Wait a second. Answer as array to be returned. Now I'm sorting these queries in naming it as sorted queries. Now I would use a priority queue to store the minimum value firstly. So this also contains row and column. Iterate. So first thing, priority queue dot push. Firstly, the value of grid 0 0 comma row and column. Row and column is something like 0 comma 0 0 comma 0. Now while pq is not empty, sorry, pq priority queue is not empty, then I would iterate or remove all the cells which are lesser than the query. So for every query in queries, points are initialized before these queries. As I said, I would instead store points for like instead of current points, I would store that points is equal to 0. And while pq is empty, so what I need to do, and pq dot top is lesser than, so top dot for something like this is lesser than query. Yes, it should be lesser than query. Then uh, go to adjacent cells if they are unvisited. So after going visited of cell is made as true. So this is how you solve this problem, and don't forget to increment the count every time. And for this answer of I is equal to count. So it would be greater if for I is equal to 0, lesser than queries dot size I plus plus. So answer of I is equal to count, return answer at the end. But this is not even the optimized solution, and if you want the code, it is in the description for this here. So I have given the second approach and also the third approach, and first approach is a TLD, by the way. Now here comes the Dijkstra's algorithm. So here I would say something like, wait a second, I would say something like this image here. Yeah. So I am given with the queries which I am sorting here again 2, 6, sorry, 2, 5, and then 6. Yes. So these are my queries. Now I got 2, I got 5, and I got 7. Sorry, 6. Keep this aside for just few seconds. So what is the minimum value to reach this cell? The minimum value to reach this cell would be something like 1 if only values which are lesser than 1, like 0, and there won't be, I guess, minus values, so there would be only 0. Now what are the minimum value to reach this cell? 2. What is the minimum value to reach this cell, which is 2 and 3, like it is 3. Now here what are the cells that I have to go through? What are the cells that I have to go through to reach this cell 3? They are just 2 cells. What are the number of cells to reach this cell? They are just 2 cells. They are just 2 cells. What are the number of cells to reach this cell? They are just 1, 2, 3, 4, 5, 6, 7. 7 cells. But why we are knowing these all those things? Let me say that for this one, as they asked 2 as the value, this one says that there is only one cell that I can visit with query of 2. So instead of something like 2, 5, and 6, instead of giving these queries, what if we are given with something like, what are the number of cells I can visit with query 1? What are the number of cells which I can visit with query 2? What are the cells with I can visit with query 3, 4, 5, and then 6, and then 7, as 7 is the only largest element in the grid. Now what if we are given like this? So just think about it. Till 2, till this 2, what are the cells that I can visit? Only 1. Till this 3, what are the cells I can visit? Just 5. Till 4, what are the cells that I can visit? So still something like 5. So for 5 is still 5. For 6, they are 8. For 7, let me show you what are the number of cells that I can visit with 7. They are still 8. So what if I stored all these values in something like a vector? Now, let us see how I can store this in such a way that I can get the answer. So now the minimum value, imagine something like for 5, for this cell 5 is the minimum value. The minimum value, as I'm saying, the minimum value to reach this cell 5, which is at 1 comma 1, right? 1 comma 1. So I would visit these neighbors of 1 comma 1 which are unvisited, and here I got 7. Now let me change the color. Here I got 7. Now see here clearly that this 7 is the maximum from 5 and 7. So to reach this cell 7, to reach this cell 7, which would be 1 comma 2, right? 1 comma 2. To reach this 7, this cell, the minimum value, as I am saying, the minimum value to reach to reach to reach a cell will be stored. I would say how, right? 7 comma 1 comma 2. So to reach cell 1 comma 2, the minimum value you need is 7. Now I would do another thing, something like threshold threshold values. Now it would be counting the number of cells for reaching 5 and 7 and these all. Let me remove all these things. So here I have 5, right? So imagine something like just I have this 3. Now here I have 1. So the threshold value for 0 comma 0, which is the value 1, is just the number of cells that I can get through is only 1. So now if I am having this 2, right, what does this threshold value? So it would be something like threshold for max value. What does this store? So this stores the number of cells that can be visited with a threshold. What is this threshold? Threshold is nothing but the query. Like something like, if I say something like here threshold for max value, here something like threshold for max value of something, here I need the number of cells that I can reach with this cell. So the number of cells that I can reach with query 1 is just is 0, right? It is 0. That if the query is 1, then I can reach 0 cells. If the query is something like 2, then I can reach only 1 cell. That means 0, 1, 2, and then 3, and then 4, and then 5. These are the threshold values, and this would have something like 1, and then 2, and so on. So this threshold for maximum value stores all the values that I can be, all the cells that I need to go through for getting this 2. But imagine something like I have the grid is something like 1, 2, and then 2 is, this is just the grid. Now I would be having the threshold values 0, 1, 2. For 0, that means I have reached 0 cells. Then the query would be 1. So the threshold value is just threshold value. So the threshold value is 1. Then I can reach 0 cells. If the threshold value is something like 2, then I can reach 1. But if it is 2, I can also reach 2 cells in total. So this threshold value stores the number of cells that required to reach the query. So now how can I find this? I would apply a binary search or the uh, whole threshold for maximum value array. It would be storing total cells plus 1. It is quite similar to the Dijkstra's algorithm. So you will be using this Dijkstra's algorithm for storing the threshold for maximum value array and apply a binary search at the end. So this is the whole code for this third approach. If you like this video, do share to your friends and do subscribe to my channel. And the whole 3 approaches, 3 links are given in the description. Go and check it. Thank you.